Presentation on data science, artificial intelligence, Beyond Buzzword Bingo. I'm Martin Kool, and next to me sits my son Joep.
Good day.
Previously, we had a discussion around supervised learning, and we'll turn to unsupervised learning. So, basically, in unsupervised learning, there are two strategies, which is called k-means, which means you run through the entire data set and you look for the most similarity. And the other one is something called the B-scan, density-based strategy. You take an item and you take the next item, you consider whether it's similar enough. And if it's similar enough, you add it to the group and you go to the next, and if not, you try the next ones until a number of times, and if no one is found, you start a new group. Yeah, and I'll demonstrate how that works. Now, is this familiar to you, Joep?
A long time ago, but yes.
A long time ago. Well, everybody knows what you need to make of this. So what did we learn in school? Well, we either learn to get the shapes together or to get the colors together. Yeah? Yes. Now, what did the computer do? Yeah, if I tell it to make two groups, it did this. So it distinguishes on color. If I ask it to do three groups, it did this. 5 groups, it actually got the colors together. For 6 groups, it did this. And 9 groups, it did this. And the interesting thing is that for the 9 groups, it distinguishes on color, but not on shape. So clearly the shape was not
weighted correctly.
Because this is what we ultimately were told in school to do, actually get the shapes together. Interesting. This is actual code. You can find it on my GitHub, the example. But the big question is, how does this magic work? How can a computer do this actually? Well, the trick is you convert to numbers. So what did I do? For all the different colors and shapes, I actually took the height, the diameter, the number of angles, number of sharp angles, the number of obtuse angles, and the number of square angles. And for color, which is difficult, I actually took the color temperature.
Yeah, I would have suggested maybe RGB values.
RGB values could be done too, but those are 3 values, and this is a single value. So that also works. Yeah. So dimensions in centimeters, the shape and the count in angles, and the coloring wavelengths in nanometers. Mm-hmm. So that's the way I actually converted all these shapes to numbers, and that is what's fed in the computer. So it doesn't actually know the shapes, but it knows the characteristics of the shape. So likewise, you can also do image recognition. So this is a simple cross. The cross is transferred to a raster. The raster is then transferred into numbers. This is simple. If you do color, you can, like you said, RGB or something like that, or red, green, and or orange and blue, whatever. And those are actually flattened. So the first line is over here, the second line is over there, the third line is over there. So you actually get a very long string.
That's basically a coordinate set.
Which is basically a coordinate set, correct? And essentially, these all becomes columns in a spreadsheet, and each one of them could be a line. So if you have multiple pictures, you actually, for each picture, you get a line in the matrix. And now you feed the computer with similar images and tell it, just like with the cats, what should be considered a symbol plus sign and what shouldn't. So We tell it that this should be considered a plus sign, although it misses these two. This should be a plus sign, although it's got these double. Although it's missing here too, it should be considered a plus, and this one shouldn't be considered a plus. And that way, that all gets transferred, and then you can actually compare all the patterns. Yeah?
Yes.
This is actually how it works, believe it or not. Yeah? Good example, this is the MINST dataset. That's the American Institute for I got lost. Sorry. It's an American institute for that actually published a written data set which was labeled. So handwriting. And those handwritings were actually put on a coordinate system just like this. And that's how the initial teaching took place. Now,
right.
You can also do something else. The subject of a newspaper article, how would you do that? Well, you can actually convert the text to numbers. You can actually count the words. Yeah? Now, this is a mock-up example, but every word gets a count. And you can tell it if it's these words occur often, it's sports, and if these words occur a lot, it's politics. Yeah? A very example would be, you can even translate documents like that. The Universal Declaration of the Human Rights, this is the most translated text in the world. If you count words, and if you take the word count, then I don't know how good your Finnish is, but the English word is right, the German word is recht, and the French is droit. And in Finnish, it appears to be oikeus. Now, I once had a Finnish person in the audience, and he confirmed that oikeus actually means recht or right. And artikla was also. Yeah. And if you actually go through this, you'll find that many of these things are actually relatively close to each other. Yeah?
Well, luckily I'm a bit of a linguist, so
yeah,
there's a logical explanation for that.
Absolutely. They even get close. But this is actually the fundamentals of how the original translation started. We're now a lot further along, but these basic word counts were the initial start of natural language processing. So it just shows you what simple word counting can do. Fallible pattern recognition. What we do up to now is very much, and that's what AI is based on, is actually pattern recognition. And why is a computer better than a person? Well, I don't know whether you've seen this come along or this one. And is anybody sensing any trouble?
Yes.
Are you?
Yeah, the hearts are black and the clubs are red and they're switched.
Absolutely. Would you believe that there are in many audiences that I've spoken to, even if I show them like this and I tell people that something is wrong, that they will not recognize that it is wrong?
Yeah,
now, why is this? I would recommend the book of Daniel Kahneman around thinking fast, thinking slow, about the system 1 and the system 2. Which basically explains that the subconscious is so strong that it actually overtakes any system 1 thought process, which is far less energy efficient, because a person is actually lazy. So you will always try to fit something in the ideas, in the context, in the
this occurs as biases and personal opinions, so things like selection bias,
absolutely,
and cherry picking.
You will always, if you want to see it, and especially if you see it short, you will try to fit it in the existing paradigms, as it is called. And your paradigm is that hearts are red, and even if they are black, you'll see red hearts. It's incredible. Well, there you have it. And thanks for your attention. Up to the next clip. Thank you.